Hello dear students, today we will discuss the photoelectric effect phenomena, a topic of quantum chemistry. In this particular topic, we will discuss the three different concepts, that is introductive part of the photoelectric effect, law of photoelectric effect, and derivation part of the photoelectric effect phenomena. Now, let's start with the introductive part of the photoelectric effect phenomena. When the high energy radiations like X-ray, UV visible radiations are strike over the metal surface, then there occur the ejection of electron from the metal surface. This type of the phenomena of electron ejection from the metal surface is called as photoelectric effect phenomena, and the ejected electrons in this process is called as photoelectrons. From this diagrammatic part, we can represent the photoelectric effect. This is the incident ray or light striking over the metal surface, and these are the ejected electrons, which are called as photoelectrons. Then we will discuss the two different laws related to the concept of photoelectric effect. According to the first law of photoelectric effect, number of ejected electrons from the metal surface are increases with the increase in the intensity of radiations. This can be represented through the following diagram. Intensity increasing, number of ejected photoelectrons. With the increase in intensity, number of ejected photoelectrons are also increases, which can be observed from this graphical representation. Then after that, according to the second law of photoelectric effect, velocity as well as energy of the ejected photoelectron is increases with the increase in the frequency of incident radiations. That means frequency increasing, number of energy of ejected photoelectron will also be increases. This can also be represented through the following graphical representation. Then after that, we will move in the final and derivation part of the photoelectric effect phenomena. According to the quantum theory, when we introduce the quanta of S nu energy over the metal surface, then total energy of incident quanta is distributed in two different parts. Certain part of quanta is consumed in just ejecting the electron out from the metal surface, which is called as threshold energy, S nu dash, and corresponding frequency nu dash is called as threshold frequency. And this is the limiting frequency or limiting energy. If any incident quanta having the energy or frequency less than this threshold limit, then photoelectric effect phenomena will not be possible. Then according to the photoelectric effect phenomena, या quantum theory of photoelectric effect phenomena, remaining part of energy of incident quanta is used in providing the kinetic energy of the ejected photoelectrons. So S nu means total energy of the incident quanta will be distributed in two different parts. S nu dash, that energy is called as threshold energy, which is just sufficient energy to eject the electron from the metal surface, and remaining amount of energy will provide the kinetic energy. So S nu dash and kinetic energy will combinedly represent the total energy of quanta S nu. Accordingly, kinetic energy of the ejected photoelectron will be Sc 1 upon lambda minus 1 upon lambda dash, And this equation gives the idea about the kinetic energy of ejected photoelectron during the photoelectric effect phenomena. Thank you.